So, I am going to deviate a little bit from thermofluidsy lab kind of stuff. And I want to talk about energy usage in our society. Okay, folks, we use a stupid amount of power. And we don't even think about it. So, we open up with a question. I think the university's light bill is for the month of July. Go for it.
500,000.
Higher.
What?
Anybody else want?
Million.
Higher.
For just the lights.
2.5 million.
A little bit lower. 1,000,006. Okay? So you wonder why your tuition's high. Okay. We use stupid amounts of power. So I'm going to do an homage to my professor back in the day, way back when. So I had this professor that I reverently call God. Dr. John Wilson was the most amazing professor I have ever seen. This guy was actually barred from being Teacher of the Year because he just took it every single year. There was no reason to have, any kind of bonus because he just schooled everybody. He could teach differential equations to a piece of chalk, and the chalk would understand. That's how good this guy was. So one day he comes into class, and he comes in with his tie, his jacket on, all professional like, and he's got his lecture all ready to go. He thinks, hell with it. He was mad at his son for taking too long of a shower. And as engineers, we understand energy and power and all that kind of stuff. So he did an example that I have never forgotten, and I want to do for you guys. So what he did is he said, look, let's take the amount of energy that goes into a 40-gallon hot water tank, and let's lift the car with it. And let's look at how high you can lift that car with the energy of a long, hot shower. So that's what we're going to do right now. Cost of a hot shower. So we're going to assume we go from standard groundwater temperature, which is about 50 degrees in Maine, to standard tank temperature of 140 F. Those same numbers I gave you back when we did the solar collector lab. And we're going to lift this. Okay, this is my midlife crisis car. This is my GTO. I love this thing. Okay, this is like old school fun. The entertainment system's under your right foot. When you say go, this thing just goes. I was doing 100 on the main turnpike with it. It's like idling. Okay, but fuzzy stuff aside. So let's take my very portly 4,491 pound GTO, and we're going to lift it up in the air. All right, so we're just going to say mass of the water in the tank times the specific heat of the water in the tank times the temperature rise equals the potential energy for lifting my poor airsick goat. Okay, got the mass of the car. I got that off the data plate on the door sill. G, we all know what that is, and H, the height we're going to lift it to. Okay, now my prof, God, he was amazing. Okay, he did it all in English units. Feet, pounds, seconds, BTU. Guys, I'm not that good. I got to do it in metric if I have any prayer of getting it right. Okay, so we go through, we change everything to metric so we can actually get it right instead of using those god-awful BTU units. We solve for height. Height equals blah, 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 do some algebra. Hopefully all you guys can do that. And finally, we throw the numbers in. The height is equal to that mass right there. And we're going to lift my GTO to 1,610.3 meters or 5,283.1 feet. So to heat a tank of hot water, you gotta lift my GTO over a mile. I have never forgotten that. And I take shorter showers now because of that. Okay, so when somebody says, we want to do gravity batteries, we want to store energy by lifting masses, I want you to just think back to this. Okay? And, that is a ton of energy. But we don't think twice about using it. So I encourage you to keep that in the back of your brain. All right, another one that I dearly love. The beloved soda can. Okay? So we are benefiting right now from global warming and the melting of glaciers because in Greenland, the glaciers are melting, the water's running off, they're making hydroelectric, and they're making a whole bunch of cheap aluminum for the markets. So, the question that I pose to you, 60-watt incandescent old school tungsten bulb. Okay? Makes a nice hand warmer, gets really hot. So, for the energy it takes to refine the aluminum in this little 15-gram can, how long can I keep this bulb on? Let's find out. Turn that off because that's one. So here's how I'm going to do it. I started off with the heat of formation of aluminum oxide. Okay? If you don't know, aluminum burns really, really nice. Okay? If you get an aircraft fire on an aircraft carrier, it is darn near impossible to put out. Thermite grenades, things that I used to use to destroy artillery pieces, stuff like that, that is nothing more than burning aluminum. And this will burn through the barrel of a howitzer very, very nicely. Okay? Highly exothermic. But the downside is when I want to make an aluminum can, I got to put all that energy back in to separate the oxygen from the aluminum. So, there's my burning aluminum equation. 4 aluminum atoms, 3 oxygen atoms, results in 2 aluminum oxide plus 2 heats of formation. Okay, cool. I multiply by the atomic weights. So the atomic weight of aluminum is 27, atomic weight of oxygen 16. All that weight's got to show up on this side, so 204. And there is my 2, and I multiply the whole thing by 1 mole, so there you go. If I cross multiply the ratio down to 15 grams, because that's what this can is 15 grams. So I do some cross multiplying. I got 15 grams here, I got 108 there. So this times that, divided by that equals that. This times that, divided by that is that. And do the same thing with the energy. So I got my energy right up there, my 465 kilojoules. And I'll just say time equals energy divided by power. So it's a 60-watt bulb, so 60 joules per second. 7,759 seconds, 2.15 hours. So the energy it takes to remove the oxygen from the bauxite to make this aluminum can, if my system were completely perfect, no inefficiencies, no I squared R resistance, none of that jazz. I could keep this bulb on for 2.1 hours. Okay, so in the real world, probably more like 4 hours, 5 hours. And this thing gets hot. I don't want to grab that bulb even now. Okay, so takeaway message, folks. Recycle your aluminum cans. Literally, it takes that much power, huge amounts of power, to make a simple little soda can. So for you guys who have never seen a tungsten bulb, so I can keep an LED bulb lit for roughly 25 hours with the same light intensity. Okay, so tungsten bulbs about 4%-ish efficient. Makes a great heater, makes a lousy light source. LED bulbs, much, much better. So 25 hours, you can have a 60-watt light source for making one can. Next example, a lowly gallon of gasoline. Oh, this is one of my businesses. Okay, you guys, it's hard to imagine how much energy is in a silly gallon of gas. And you know, every week I pull up to the pump, I put 17 gallons in my Pilot, which I hate because the goat's so much more fun. But you know, I can get the goat stuck in the driveway on 1 inch of snow because it has no traction. Okay, so let's go back to our first lab. So you guys found out it takes about 6 hours to heat a tank of hot water with a 4x8 solar collector. Okay? So how long would it take with a 4x8 solar collector to gather the energy of 1 gallon of gasoline? So we'll start with the heat of combustion. 127 megajoules per US gallon. That is a whole lot. Okay, and that is the lower heating value. So we burn the gasoline, but we do not condense out the steam from combusting it. So it's a hydrocarbon, you burn it with oxygen. The hydrogen gets converted to water, but we don't condense it. So when I did your solar collector lab, I got 483 watts per meter squared as the energy actually captured with the black aluminum plate. Okay? And then I'm going to use power collected is equal to flux times area. Collector area is that number, which you guys have all calculated before. So the power collected by a 4x8 solar collector, simple black Rust-Oleum, is 1,435 watts. So in my mind, what does that mean? Collects the same energy as a hair dryer. Hair dryer is about 1,500 watts. That's one of my favorite metrics. Okay, so then we'll just do a little math magic. So time equals energy divided by power. Time equals 127 megajoules divided by the energy coming into the collector. And that gives us the time to gather that same amount of energy, 18,809 seconds, or 24.6 hours. Gather the energy of 1 gallon of gasoline with a 4x8 solar collector, simple black flat plate. It's going to take you about 4 to 5 days. That's how I know gasoline has a whole lot of energy. that black plate got pretty hot pretty fast. But it really wasn't jack compared to what we use. So for you folks, your energy usage is going to really change. And there's a whole lot of opportunities out there for you guys. Okay, heat pump technology, it's going to take off. It has to. We can't keep using power at these kinds of levels with a growing population and think that's sustainable. It's not. Okay. When I was in school, we actually did a calculation. We said, let's say that the entire planet is just one ball of oil. Okay? Based on the current exponential growth in usage, how long would it last? And it turns out in about 200 years, if the entire planet were just a ball of oil, we would burn the whole thing up. It's gonna change. So what I would say to you guys is, okay, it's gonna change. Doesn't mean it has to be scary. I say that that's your opportunity to be a billionaire. Okay? Things like cogeneration, making electricity while you make your heat for this building. Huge opportunity. Massive power. I might beat you to it, I don't know. I would dearly love to make a little shoebox-sized jet engine with 100,000 hour overhaul time that can, have a little generator attached to it. Maybe it makes 2 kilowatts, something like that. So I take the exhaust off, I heat my house, I take my 2 kilowatts, run all the electrical in my house, sell back whatever power I don't need. That's something you guys could do. I'm no genius. You guys are smarter than I am. Your math skills are better than mine. I haven't done an integral in like 30 years. Okay? So if you guys were ever freaked out by the amount of math that's being thrown at you, don't be. Okay? I worked on the Raptor, I worked on the F-35, that was not an integral in sight. It's just the way it works in the real world. So, there you go. There's my speech for 365. All right, short class today. Your rewrites, make sure you get them in by midnight. It is not optional. There was some rumor floating around about that. Put that on your brains. So get your rewrite in by midnight. And I look forward to seeing you guys at 375. Are there any questions? Anything you guys want to ask? You are free to go. Good. I was doing 105 on the main turnpike in the middle of the night, and I was afraid I was going to run into a moose. So I have never topped it out. That is far too scary for me. But I did watch an episode of Top Gear, but